Hey, Keith Van Wimmer, Van Tech Consulting. Today we're talking about hopefully a brief video on these guys. These are Exfo EUIs or Exfo user interfaces, and these guys here are little FC Frank Charlie's, and they got this little dust cap on it, and it snaps in and everything. So the problem with this is that these dust caps are these guys. And this right here is just a V in the plastic. This is what's called a living hinge. And as we know, if you have these, everybody that's owned an Exfo, this cap breaks at this living hinge. I mean, anybody that's had something with a living hinge, this is a very inexpensive, cheap hinge to make when you do injection molding. You get it in your little plastic boxes that, little tackle boxes or little component boxes. If you've ever ordered screws off of Amazon, little box of screws, they do the injection molding. And again, this is just a really cheap hinge. When you get these from the factory, they're pretty much flat. I mean, they've been injected, molded, and they come out of the injection molder. But as soon as you put them onto the adapter, you're already starting to create this stress here. We went on a quest and we said, well, there has to be a better way. I can probably, as I've embraced 3D printing, I can probably just design something and make something less expensive that people can replace. So we started exploring living hinges in different materials, looked at nylon and created a living hinge, and, did this on this hinge about, 500 times, and everything seemed fine on it, and seemed pretty tough. These guys here are probably some kind of HDPE, so high density polyethylene. This is nylon, so a little bit stronger than this kind of stuff. Again, we did a couple of these, did a couple tests on it, stress tested them. It seemed to work okay. In reality, once you start doing these in nylon and prototyping this, the same thing happened. The living hinge, it just snapped off there. Any torsional kind of stress. So it worked fine this way, but as soon as you twist that, so as you're closing this, if you twist it at all, it just snaps off. So we thought, well, you know what? Maybe we can come up with something. And I'd read about what they call flexible filament, and I figured maybe we could do something using a flexible filament. So tried doing this again. The little hinge just it ended up getting thin and ripping off. So what I like to teach folks in fiber and copper testing is, don't get caught up. Don't put the blinders on. Think outside the box. Is there something else that's affecting this? And so I thought about it and said, man, there's got to be a better design. And we came up with this guy. And this is the design. This is, again, this is made out of a flexible filament. As you can see, these guys are they're flexible. They'll bend, but, they're still fairly rigid. The other thing on this is that this little guy here, much like the connectors, so there's a little dog here that goes down inside of the of a little slot right here on this, and it catches. There's a little lip down there, and it catches on that lip, and that's what's supposed to keep that closed and keep the dust out. Well, if that starts to wear, these things constantly are flopping open. So guess what? Dust is getting in there. So we want to alleviate that. So once again, I said there has to be a better idea, and then we came up with this kind of thing. So this is a flexible filament. This is you can see that this is fairly thin. This is just the brim, and trying to even rip this is just impossible. Tearing this stuff off. It's incredibly flexible and strong. Again, this material is extremely tough. This This is just a small sample, but it's only 0.009, so 9/1000ths of an inch thick. These guys here are like 25/1000. So, I mean, just to give you an idea, that's pretty amazing. It's extremely difficult to print in this size. Evidently, you know, as I keep going and reading on with 3D printing, the smaller your parts are, the more detail to them, the more challenging it is to print these. So again, these we've gotten these to be repeatable to print. The way they work is they just fasten to the same screw holes back here, but they are a friction fit, and they basically just slide over. And you can put these all the way down. I mean, if this is mounted into your equipment, you've got coverage. And you know, the adapter here, if we hold one up, you can kind of see how much it's engaged. I mean, there's a lot of engagement there, almost 1/4 of an inch of engagement. So that's a fairly reasonable seal around this whole thing. The deal on these are, I don't have any empirical data on this as far as how long they'll last in the field, but I'm going to go with, you know, quite a long time. I mean, they're extremely strong. You can pull on them. You know, very flexible. You're not going to, you know, you're not going to get the what do you want to say, the fatigue in the plastic. They just go right back to wherever they were. You know, again, I think this is a much better, cleaner idea as far as a cover. It's much more secure and a lot more what do you say, usable. It's also going to give you a better seal. Anyway, these will be available on our on eBay, and got to work up a price on them, but I'm going to guess they're going to be somewhere between 12 and 15 bucks in each, where these guys, and this will probably be about the last cover that you ever buy. Whereas these guys here are something like, I say, about 30 bucks or 32 bucks or whatever from Exfo. So anyway, give it a shout. If you want some of these, let us know. We'll get them made up for you and shipped out. Again, I hope this was useful information, and we will talk to you soon. Thanks for watching.